When NASA released the confidential findings of their latest propulsion test, the scientific community braced for a ripple. Instead, they got a tsunami. After decades of chasing the dream of faster-than-light travel, a veil was finally lifted to reveal what many had whispered about in secret corridors and theoretical physics forums. NASA had developed a propulsion system so advanced, so fundamentally revolutionary, it could reach the speed of light. Not near light speed, not relativistic speed, actual light speed, 186,282 miles per second. The implications of this admission are staggering, threading together the audacious dreams of science fiction with the increasingly bold trajectory of modern physics. Before we start, smash the like and subscribe buttons for more updates. At the heart of this breakthrough is a propulsion system that transcends conventional rocket dynamics. NASA's engineers, collaborating with an elite cohort of quantum physicists and materials scientists, built a prototype engine rooted in principles that were, until recently, considered theoretical or outright impossible. They've seemingly harnessed the elusive qualities of zero-point energy and quantum vacuum fluctuations, phenomena that tap into the latent energy of empty space. This energy source, until now intangible and immeasurable in practical terms, has been tamed through quantum field manipulations and advanced containment methods involving metamaterials not found in nature. The result? A drive mechanism that uses the inherent energy of the vacuum itself, requiring no fuel in the traditional sense. This engine, colloquially dubbed the light drive among the engineers involved, does not function by Newtonian principles. It doesn't push mass out to move forward. Instead, it reconfigures space-time itself on a minuscule but controlled scale. Echoing the Alcubierre metric, a once purely theoretical model that described bending space-time to allow faster-than-light travel, this technology manipulates the space in front of and behind the craft. Compressing space ahead while expanding it behind, the craft technically remains stationary within a warp bubble, with space itself doing the moving. Light remains the cosmic speed limit locally, but this drive bypasses that limit by altering the fabric of space-time. The experiments that led to this development were shrouded in secrecy for years, operating under code names and buried within the layers of NASA's Deep Space Propulsion Initiative. However, leaks and fringe science speculation forced the agency's hand. When the data became irrefutable, NASA made the bold move of acknowledging the existence of the light drive, though the admission came with careful wording and extensive disclaimers, all of which did little to suppress the shockwaves sent through the scientific world. At a test facility far from the public eye, a prototype vehicle, no larger than a family sedan, was launched within a controlled vacuum chamber enhanced with magnetic field stabilizers. Initial calculations suggested it might reach a significant fraction of light speed, perhaps as high as 70%. Instead, the craft vanished in a flash of brilliance, crossing the threshold of light speed itself. High-speed sensors, running at 1 billion frames per second, confirmed what previously existed only in simulations. For a split second, the vehicle occupied a relativistic frame. Then it was gone, leaving behind data that would be parsed for years, if not decades. This breakthrough brings with it the end of the tyranny of distance in space exploration. Once, Alpha Centauri, our nearest stellar neighbor at 4.37 light-years away, was a cruel symbol of cosmic limitation. With conventional propulsion, even the fastest probes would take tens of thousands of years to arrive. Now, with light drive technology, such a journey becomes feasible within a human lifespan. A trip that once seemed the stuff of interstellar fantasy could, in theory, be completed in just over 4 years. For generations raised on Star Trek and Star Wars, this is the moment where fiction collides with physics in the most spectacular way. From a technical perspective, the challenges overcome to achieve this propulsion are nothing short of monumental. First came the problem of energy. Extracting and stabilizing zero-point energy without causing destructive quantum instabilities was long thought impossible. The breakthrough came when NASA scientists developed a containment lattice made from programmable metamaterials capable of dynamically adapting to quantum stress. These materials are constructed on the atomic scale, allowing them to bend electromagnetic fields and manipulate energy signatures in real time. With this technology, they were able to create and sustain a quantum vacuum energy gradient, a prerequisite for triggering the space-time compression that powers the light drive. Another major hurdle involved navigation. Traditional spaceflight relies on inertial guidance systems and reaction-based control surfaces, both of which are rendered obsolete by lightspeed travel. Navigation at such velocity required a complete overhaul of spacecraft orientation and destination tracking. NASA devised an AI-assisted navigational matrix capable of anticipating gravitational wells, spatial anomalies, and time dilation effects in real time. This AI is not merely reactive, it preemptively adjusts trajectory based on predictive modeling drawn from quantum entanglement data and stellar positioning far beyond the visible light spectrum. Of course, reaching light speed introduces more than mechanical and navigational challenges. Time itself becomes an obstacle. According to Einstein's theory of relativity, as an object approaches the speed of light, time slows down for it relative to an outside observer. The light drive's unique manipulation of spacetime neutralizes this effect within the warp bubble. Time remains linear inside, even while the bubble itself zips through the universe at light speed. This temporal insulation means that a crew on board a light drive ship would experience travel to a distant star system in real time, without the paradoxical aging disparities predicted by relativistic travel. The light drive represents not just a technological leap, but a philosophical one. It forces humanity to rethink its place in the cosmos. The stars are no longer untouchable specks in the night sky. They are destinations. The galaxy, with its billions of potentially habitable worlds, is no longer beyond reach but within grasp. The existential implications are profound. What does it mean to be human when the boundaries of our existence stretch beyond our solar system? What does society look like when a person can travel to another star and return before their family has aged more than a decade? NASA's admission also signals the beginning of a new geopolitical era. Space has long been a theater of competition, but lightspeed travel changes the very rules of that game. The nation or coalition that harnesses this technology first and most effectively could dominate access to extraterrestrial resources, habitable planets, and deep space scientific discovery. It introduces a new type of space race, one not defined by orbit or lunar landing, but by interstellar reach. It's likely no coincidence that NASA made its admission at a time when other spacefaring nations are accelerating their own exotic propulsion research. It's both a warning and a proclamation. There is also a psychological reckoning ahead. Humanity has always looked to the stars as symbols of the divine, the unreachable, the ultimate mystery. Lightspeed travel dissolves some of that mystery and replaces it with opportunity and responsibility. The exploration of the cosmos, once a matter of distant dreams, becomes a moral and cultural imperative. How will humanity engage with new worlds? What principles will guide our first steps into alien solar systems? Will we be explorers or conquerors, scientists or settlers? The admission by NASA reshapes even our understanding of physics. The light drive demonstrates that long-standing assumptions about the inviolate speed of light may not be limits, but thresholds. The development validates alternative interpretations of quantum field theory and gives credence to fringe hypotheses that mainstream physics once rejected. The line between science and science fiction is thinner now than it has ever been. Future theoretical work will likely be inspired by this success, leading to new models of the universe and possibly even breakthroughs in understanding gravity, dark matter, and the unified theory of everything. It is hard to overstate how profoundly this changes human destiny. Lightspeed propulsion is the key that unlocks the galaxy. Entire worlds, once forever out of reach, now become tangible possibilities for colonization, observation, or preservation. The expansion of human civilization beyond Earth no longer belongs to the hypothetical. It becomes an active trajectory, supported by real engineering, scientific rigor, and finally, proof. But the technology also presents dilemmas. Who decides where to go first? Who funds these missions? How are the risks distributed? And who accepts responsibility for any unintended consequences? These are questions that lie in the immediate future and will shape global policy, space law, and ethical discourse. Yet the most pressing implication remains the one that brought humanity to the stars in the first place: curiosity. The light drive is a vessel of that curiosity made real, a triumphant cry in the face of cosmic silence. With NASA's breakthrough, the final frontier is no longer a poetic metaphor. It's a coordinate, a place on a map. And though the engine that makes it reachable is a marvel of science, it is still powered by something older and more elemental than any quantum particle: the human desire to go farther, see more, and understand what lies beyond. This is not just a leap forward, it's the first step on a path without end, illuminated by the light we now travel beside. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on NASA reaching light speed? We want to hear from you. Thank you for watching and see you next time.